Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Well, guys, Newton's first law of motion, the definition which I am telling you about this will also be given in the video description, inshallah. So don't worry if you don't remember the definition, but you must understand that what I'm going to tell you. Here I have drawn a horizontal surface. On the horizontal surface, let us suppose a block of wood is, this is a block, wooden block or any body. Okay, this block, if it is lying on a surface, if we are not applying any force on this block, then this block will not move. So in the absence of an external force, the body which is at rest will remain at rest. So remember this fact. This is a fact that if you are not going to apply any force on a body which is in stationary uh, position, so it will not change its position until you apply a force. Okay, so this is the first part or the Newton's first law of motion, that in the absence of an external force, the body which is at rest will remain at rest. And this thing is your daily experience, that if you have placed any book in your on your table, etc., so it will remain there until you pick it up or you apply some force. Okay, this was the first law, first part of the first law. Now, for example, another body which is moving, this I am taking an example of a ball. If this ball is moving, it will continue its motion in a straight line. If the ball is moving, if the ball is moving, it will continue its motion in a straight line with uniform velocity unless acted upon by an external force. So if I say, then in the absence of an external force, the body which is at rest will remain at rest, and the body which is moving will continue its motion with a uniform velocity. Now, but in your daily experience, you see that this is proved in your daily experience. But you see, when you throw a ball, the ball falls down after covering a certain distance. Why this ball falls down? Basically, what is happening with this ball? This ball uh, is under the uh, 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 under two forces. This ball will fall down. Actually, one force is the pull of the gravity. There are two forces which are acting upon this ball. One is the force of gravity, which is the weight of the ball. Okay. And the other force is the air resistance. Air resistance. So these are the two forces which are acting upon a ball when it is moving in a straight line. So if we are able to remove these two forces, then you will see that if you will throw a ball, it will continue its motion in a straight line. So the Newton's first law of motion says that in the absence of an external force, that is why I am using the word that in the absence of an external force, the body which is at rest will remain at rest, and the body which is moving will continue its motion in a straight line with uniform velocity. And I told you that a ball which you throw falls down after covering certain distance. Why it falls down? Because it is under the two forces. One is the weight which is pulling it downward, and other is the air resistance. If you are able to remove these two forces, then this ball will continue its motion. If throw this ball in space, then it will continue its motion until it comes within the ambit of the gravitational pull of any other planet, etc. Okay, so here the friction is basically the air friction. Okay, so because air is causing the friction, air friction or air resistance. You know that uh, air particles are causing air friction for the movement of this ball. Okay. Well, now this Newton's first law of motion is also called law of inertia. Law of inertia. Remember this, Newton's first law of motion is also known as the law of, as I told you that Newton's first law of motion is also called law of inertia. If somebody asks you that what is law of inertia, then you can tell the definition of Newton's first law of motion, that in the absence of uh, external force, the body which is at rest will remain at rest, and the body which is moving will continue its motion with uniform velocity in a straight line. Okay, now the question is, what is inertia? What is inertia? Actually, I'm telling you a precise definition of inertia. Basically, inertia is the characteristic property of a body which helps the body in doing whatever it is doing. Or we can say that inertia basically resists any change in a state of rest or of uniform motion of a body. Okay, so inertia basically is resisting any change in the state of rest or of uniform velocity. Now, to understand this fact, let me think about a daily life example. If you might have experienced that if you are traveling in a bus, okay, and all of a sudden bus stops, okay, all of a sudden the bus stops, then what will happen? What will happen basically? The passengers who are standing will fall forward. What is happening here? Basically, the passengers which were traveling with the bus and the bus was also moving, they were going in forward direction. The bus was also going in forward direction. All of a sudden, the bus stops, but the passengers are still in a state of motion. The as the passengers were standing on the bus, all of a sudden the bus stops, but the passenger, due to inertia, keeps their try to maintain their state of motion. Passengers try to maintain their state of motion due to inertia, so that is why they lean forward, they may fall forward. In the same way, if the bus is standing and some passengers are also standing on the floor of the bus, then all of a sudden the bus starts moving. What will happen? The passengers will fall in backward direction. Why? Because all of a sudden the bus has started its movement, but the passenger are still in a state of rest. So due to inertia, they will try to maintain their state of rest. In trying this, they will fall in backward direction. Let me have an example of the same. If you might have tried this example, just think that if you might have tried this at home, if you have a coin, okay, well, you might have tried this at home. As I told you that inertia is the characteristic property of the body which helps the body in doing whatever it is doing. Now, here you can see that here is a glass of water. Here I have a cardboard and a coin. I have placed this coin on the card. Okay, now I'm going to give you an example of inertia, that this coin is lying on the cardboard and I have placed this cardboard on the glass. Now what I'm going to do, suddenly I will move this card. The moment the card will move, the coin will drop into the glass. So look at very carefully that what I'm going to do, like, oh sorry, actually uh, it didn't work due to some Space problem. Okay, now it may work. Well, so here you have to give a, like this. You can see that I moved the card, but due to inertia, kept the coin tried to maintain its state of rest. So that is why the coin fall down in the glass, but the card was removed under this. Again, you can watch this that I am both the card and the coin both are at rest. All of a sudden, when I am given a sudden movement to the card will move forward and the coin will fall into the glass. This is an example of inertia. I think so you people might have tried it already. So remember this, that the inertia is the characteristic property of the body which helps the body in doing whatever it is doing. So remember this Remember this, that in inertia, the coin tried to maintain its state of rest, but due to the sudden movement of the card, the coin could not maintain. So it tried maintain, so it fall down into the glass. Now, I hope that this Newton's first law of motion, which is called law of inertia. But remember this, you should not confuse the inertia with the law of inertia. Law of inertia is the Newton's first law of motion, but inertia is the property of a body which resists any change in a state of rest or of uniform motion. Now I am going to discuss Newton's second law of motion. Newton's second law of motion. It is also very simple law that whenever you apply a force on a body, please listen to me carefully. When a force is applied on a body, then it produces an acceleration in a body. As I told you that to produce an acceleration, you need a force. So whenever you apply a force on a body, that force produces an acceleration in the body. Now, how much acceleration is produced? That acceleration basically is directly proportional. That acceleration is directly proportional to the force applied. It means the greater the force and greater will be the acceleration. Okay? It means if you are applying more force, then more acceleration will be produced. Well, so you know that if you are applying lesser force, so lesser acceleration will be produced. So it is very clear. For example, if you are applying a small force on a ball, then it will accelerate slowly. But if you are applying greater force on a ball, a greater acceleration may be produced in a body. It means that acceleration is directly proportional to force. Greater the force, greater will be the acceleration. Remember this. Now, other thing, that acceleration basically is inversely proportional to the mass of the body. If the mass is greater, then lesser acceleration will be produced. For example, you have a ball and you have a brick. You have the same force. You have a ball and there is a brick. You are applying on both the bodies, say 20 Newton force. On the ball, again, you are applying 20 Newton force. The same force of 20 Newton is being applied on the ball and the brick. Obviously, a tennis ball has smaller mass and the brick has much more than that. Okay, so you are applying the same force of 20 Newton on both. So obviously, that 20 Newton force will be able to produce greater acceleration in ball, but that 20 Newton force cannot produce much more acceleration in brick as compared to the ball. So that is why the acceleration is inversely proportional to the mass. So it means greater the mass, lesser will be the acceleration. Lesser the mass, greater will be the acceleration. So basically acceleration is depending upon the mass of the body. Okay, so remember this, that if the force is greater, then more acceleration produced. Now we are going to join these two. If we are going to join these two, A is proportional to F over m. From here we get an equation that A is equal to F over m. Briefly, I am telling you the equation for the second law of motion is F is equal to ma. Remember this equation, this F is equal to ma. F is the force applied, m is the mass of the body, and a is the acceleration. F is the force applied, mass m, and a is the acceleration. So this equation is called Newton's second law of motion's equation. I am telling you again the law that when a force is applied on a body, that force produces an acceleration in the body. That acceleration is directly proportional to the force applied, and that acceleration is inversely proportional to the mass. If you are writing a quantity inversely proportional, then you have to write 1 over that quantity. If you are showing inversely proportional, remember this. I think so you have done this chapter in mathematics in which you are doing directly proportional and inversely proportional in class 8. I hope you understand this sign, that for directly proportional quantity we have to write like this, for inversely proportional we have to write like this. Okay. Okay. Well, Newton's third law of motion states that to every action there is always equal but opposite reaction. Or simply you can say that the action and reaction are equal but opposite in direction. Okay, let us have an example. For example, if you are throwing a ball towards a wall. You are throwing a ball. You throw the ball towards the wall, and the ball goes towards the wall. As a reaction, what happens? The wall applies a force on the ball, and the ball will come with the same force in opposite direction. In the forward, the force was given by you on the ball, and that ball will carry the force and will strike with the wall. When it strikes with the wall, what happens? Basically, the wall exerts a reaction force. First of all, the ball was exerting a force on the wall, but as a reaction, the wall is now exerting the same force on the ball, which may be taken as minus f. This negative sign is showing that the direction of the motion is opposite. Okay, so remember this, that this negative sign is showing that this is the opposite direction of the first force. The first force I am taking as positive, and the reaction force I am taking as negative. So remember this, that action and reaction are equal but opposite. Now let us have another example in which I am going to discuss the example of a table. Suppose this is a table, a block is lying on the table. The block is lying on a table. What is happening here? Actually, the block is exerting a force on the table. Now, how much force is this block exerting on the table? Now, the question may arise. I may ask the question that how much force this block is exerting on the table. On the table, actually that force is equal to the weight of the body. That force which this block is exerting on the table is weight of block, because you know that weight is also a force. So this block is exerting the force equal to its weight. If you are sitting on the chair, then how much force you are exerting on the chair, that force will be equal to your force. Okay, now this was the action force. this is action force because this block is exerting a force equal to its weight on the surface of the table. As a reaction, the table surface is also putting the same force on the block, same amount of the force, which is called the reaction force, represented by R. These two forces of action of the weight and reaction by the table surface are equal. So that is why you can see that the body is lying on the table. Okay, so if you are sitting on the table, these two action and reaction forces are equal. That is why you are sitting, you are sitting on the chairs, etc. Or if you are placing something on the table, that remain on the table due to the equal amount of these action and reaction forces. Actually, this is a basic application of the Newton's third law of motion, basically. So remember this, the weight and normal reaction. This R is called normal reaction. Normal reaction. Because normally upward it is, if it is weight is vertically downward, then normal reaction is vertically upward. So this is called normal reaction because this reaction is at 90 degree with the surface of the table. You can say it like that. Okay, so normally we say that this is a normal reaction, and the question related to this weight and its normal reaction may also be asked in CAIE examination. Well, so we discussed that what is the Newton first law, second law, and law of inertia, and the third law of motion is discussed.